And thanks, Mark. And Yasushi, thank you for everything you've done to bring me here. Yasushi told me that his students are going to achieve better grades if they move closer to the front. No, that didn't land, did it? No, okay. Thanks for having me. I really appreciate it. I'm from Salt Lake City, Utah. If you're not familiar where Salt Lake City is, it's on the edge of the Wasatch Front ski territory. Please visit, come. I'm a bit unique in that, yes, I do have many children. One wife, but many children. And this is Lindsay and my kids. And the boy in the lower left-hand corner is Owen. He has his leg broken. This was last year. We pretty much have one of our kids in this situation at any given time. So in order to avoid having to parent all the time, my wife and I travel a lot. We go to factories and job sites throughout the world. I just recently got back from Japan. And because I like to go visit buildings, which all of you do, my wife isolated me one year in the summer in the Caribbean on a cruise ship. But what do you think happened on the cruise ship? I was really interested in this, right? This is an incredible building, by the way. It is unsustainable, I will say that. However, it does take care of thousands of individuals' waste and is able to process it. We had an opportunity, my wife's a chef, and we took the tour. If you're ever on a cruise ship, take the tour of the kitchen, the back of house operations. It's absolutely incredible to see how they can take care of that many people in a small space. Because I'm interested in production, how things are made, today I'm going to talk about why, what, when, and how of what's called off-site construction or prefabrication. So let's start with why. Why are we even talking about this? If we think about the production of buildings compared to other production industries, say the production of this water bottle, right? Buildings are unique when compared to this water bottle in three distinct ways. I might call them the peculiarities of construction or architectural production. Number one, the site or the place in which the building is made, unlike this water bottle, is unique every single time. The program or the form of this and what function it has to serve, the program, is unique every single time. And the labor that is used to produce buildings is mutable and inconsistent every single time. So how can we expect to become better at producing something when those three things are always working against us with regards to efficiency in producing buildings? I would argue that one way in which you could think about this is trying to leverage the resources and sensibilities of manufacturing in as much as they are applicable or appropriate and apply them to construction so that the site, although it is unique every single time, does not have to be in majority. You can build the majority of the building in a controlled factory environment in the same place every single time, thereby increasing quality. The program, although it being different and the form being different in every single building, you could use elements within that building that are the same and mass-produced. This has been shown over history. You could even go to say the individual brick is in fact that, but thinking about that at a much larger scale as we think about chunking buildings into larger forms. And this building, albeit I don't agree with the aesthetics, is in fact a modular building in the middle in the UK. Labor, mutable and inconsistent. In the factory, it is controlled. It is the same labor force that produces these products. So we can take much of the inefficiencies that we find in what might be called on-site or site-produced in situ construction and pull them into a controlled environment, thereby overcoming some of these peculiarities and mimicking more what we see in production industries outside of construction. The history of industrialized building or factory-produced building is long. This is not a new idea. If you've taken history from many of your professors here, you students or professionals, you know that this history is rich. I like to separate this into two different categories, however, one called industrialized architecture and the other called industrialized building. Sometimes these things overlap, but if you look at the history, they are quite distinct things. And if we look at industrial building, the ones in yellow are what I would call successes, meaning they served the masses. They helped people find shelter. They were affordable. Okay? This is primarily talking about housing. The ones on the top are all architecture prototypes. They were one-off and they were never mass-produced. So it's interesting that we don't really find any solutions in the architectural realm that had an impact on society outside of a movement, a Gestalt movement, or some kind of aesthetic movement. What I am interested in, the precis for this talk, is I'm interested in architecture serving more than just a prototype or an idea, but housing people and providing shelter in an affordable way. So what do we learn from these lessons? These are 4 lessons I've pulled out and written about. One is from the history books. Proprietary systems, that means systems that are developed primarily by architects that are very unique and the details are very unique, are difficult for mass housing. And that's because they are difficult to reproduce. I'll give an example of Jean Prouvé, who was an industrialist but also an architect, French, who built some beautiful, beautiful things. But they were all proprietary, and when they needed to be replaced, there was no one to do so, right? There's no factory to support that. Whereas the simple 2x4 wall is incredibly mass-produced, and it's also very easy to adapt over time. Offsite, or prefabrication, is the research and development of a technology. In so much as a formal idea or an aesthetic idea might be there in an architect's mind, ultimately the technology does have to play through and work. Offsite, more importantly than this, though, is a business plan. And we've seen a lot of architect-led prefabrication companies pop up. There are many here in California as well. And the challenge with that is that architects, we are not trained to think about the business model first, right? That's not where we succeed. But if there is no business plan, if there is no business platform, the product won't succeed. And finally, offsite or prefabrication is contextually contingent. That is, the forces around it, the market forces around it, and the demands of the client and the users start to formulate whether it exists or not, or whether it has propensity to live or not. And I'll talk more about that. Why? Why is it happening now? We've seen it in history, and it's kind of a resurgence currently, this idea. If we look at this, we did this research project with Cumming Corp, demonstrated that coming out of the recession, construction volume is at an all-time high. I think you would agree. You see around the city all these buildings being built. Salt Lake City is the same thing. It's happening around the country. But the labor that's available to meet that demand of volume of construction is just not there. From the top to the bottom, there are not enough architects and there are not enough commissioning agents at the end of a built project to get the HVAC system going, okay, across the board. So how do we deal with this fact that there's a gap? Well, a lot of owners and developers and contractors are going to off-site methods to try and solve this problem. If there is a cost premium, they don't care because they have to get the work done. And therefore, it's finding a lot of root. And that's a good thing, I think, because it's building capacity and capability within these factories that could lower prices ultimately, once we're out of the recession, to serve the construction industry. Furthermore, if we look at CII data from 2011, this has not been updated since. This is kind of an old number. What it shows is that in the manufacturing sector, outside of construction, about 62% of all activities can be considered value-added activities. That means they provide income or jobs. About 12% can be considered wasteful activities. They don't generate anything of value. That's flipped in the construction sector. So most of the activities that happen in the construction sector, including the design all the way through construction, can be considered wasteful activities. I'll give an example of anyone who has experience in practice. Shop drawing submittal is a wasteful process. It actually doesn't generate anything at the end of the day, but it's something that's done from a liability standpoint. That's why it exists. So we did a study where we analyzed a Toyota Scion, which is a baseline model car. How much does this sell for on the market, do you think, baseline? New? 17, yeah, 15 to 17,000. And on the right is a non-load-bearing fire-rated partition wall insulated for sound attenuation, 2 layers of gypsum board on either side and lined. Through the life cycle of performance, these cost the same amount of money, right? So the question is, why can't we do that on the left? What's the problem, right? And not only that, but that keeps you cold and hot for about 15 years before it dies, right? And then there's an incredible way to recycle the thing on the left, whereas on the right, it goes into the landfill. But we do know that offsite is offering some other benefits. Schedule. It's been documented ad nauseum that schedule is the primary benefit of using a factory-built process. And that's because you can be doing all of your site work whilst you're building elements in the factory, and thereby concurrent scheduling and overlapping, you can reduce the overall time savings. This is a chart from CB Insights that shows the word prefab, building, modular home, and its use in a search in Google Analytics from 2012 to 2017. And you can see we're currently at an all-time high of using this word in the media. It's popping up all the time. So there's another reason why it has a lot of popularity. We're also at an all-time high of investment in this particular idea. So these are all companies that have started in the last 18 months on investment capital, primarily from the IT industry. So at the top is Katera out of Phoenix and Seattle. They have just announced their second round of funding. They now have a total of $1 billion of investment funding in that company. It's incredible. I don't even know an IT company that has $1 billion to start it. They own a CLT factory up in Seattle, and they own a modular building company down in Phoenix area. Then you go down the mark of all these different companies. Some produce modules in China or Poland. Down at the bottom is Plant. It has about $1 million of investment. And so this is across the spectrum. Last 18 months. There's a lot of companies who are trying to capitalize on this idea. So the question of why is this happening? It's because the economy is currently good, and people who've made a lot of money in IT are looking for other industries to try and disrupt. And people see the construction sector and say, wow, what a screwed up industry. Let me invest in that industry and try to fix it. These are also companies that have recently said in the media that they are looking or using off-site construction, in particular modular. On the left, Hilton Hotels, Marriott Hotels, and Citizen M Hotels. Marriott will build 15 to 20% of all their new product this year in modular construction using 3 factories in the United States. They just announced. IKEA has a product out of Sweden called Blvd. It's very popular, widely accepted, and it's a partnership with Blvd, who's the modular builder, IKEA, who fits it all the lifestyle furnishings out on the inside, and Skanska, who's a large general contractor. Muji Homes has a prefabricated series, both in single family and multifamily. Muji is IKEA for Japan, essentially, I guess you could say. And then Toyota has a line of homes. They build about 1,800 homes a year in Japan called Toyota Homes, and they actually have a factory they're trying to set up in Texas as well. On the right, Google, Facebook, and Amazon have all said that they want to use this primarily in their workforce housing for their IT campuses. Affordable housing is a big push in this direction currently. If we look at the units of affordable housing available per renter, for eligible renter, 100 eligible renters, we can see that, in the red, we have 30 or fewer affordable units available for every 100 eligible renters. Whereas in the yellow, it's a little bit better. So we do know that it's the coasts that really have this affordable housing issue, and there's a dearth of affordable housing across the country. These 3 cities, New York City, Philadelphia, and San Francisco, their mayors have all come out publicly in this news and stated that modular construction is a solution for them in their affordable housing crisis. So this is another reason why we're seeing this have a lot of traction currently. And then I don't think this is a big reason, but it's worth mentioning because in the U.S. currently in the political climate, low carbon is not necessarily a word we hear very often. But this is a study done by my colleague who's at the University of New Mexico now, John Qualley. And he worked with industrial ecologists at Yale University, where they documented fourplexes built through modular construction in wood and also stick built. And what they analyzed was the total life cycle of these. And in fact, yes, modular is lower from a carbon investment standpoint, but it isn't because of the waste factor, which you would think, right? Less waste in the factory. That was a very minuscule contribution to the study. What they did find, John will tell you, is that it was the carbon saved in workers going to and from a job site every day versus just going to a factory and staying there all day. So it was the transportation component that was the big deciding factor. What am I talking about? Sometimes when I talk about offsite, this is what comes to mind, right? In fact, this is the primary outcome of our prefab initiatives post-World War II, when the Housing and Urban Development Secretary, Mitt Romney's father, George Romney, produced this program, Operation Breakthrough, right? And we set up all sorts of factories and started to get ready to produce homes, high-quality homes. What shook out after that, Nixon cut the program. You can read the history. And what shook out from that was a new code by Housing and Urban Development, HUD, called the HUD Code. And that led to manufactured houses. So they're built to a lower code standard. But many times and it has a stigma associated with it, so many times when we talk prefab, this is the image that comes to mind. But we're not talking about this. We're talking about everything but that, okay? So on the left, you see in 2000, 2002, Dwell magazine came out with a competition, and they commissioned architects to think about how they could design prefabricated houses, and they've teamed with factories. And what that produced was this image of off-site construction being little modernist dwellings. And sometimes when I talk about this, that's the image people have in their minds, right? It's these cool little designed tiny houses or smaller homes. That word that's being used associated with that was something Dwell popularized called prefab, or prefab architecture, or prefabrication. Another word that's used often in reference to this is industrialized, or industrialization, industrialized building, industrialized architecture. And that harkens more to the factory environment and talking about what the factory does. Then there's modular, which really became popular under Bemis, Alfred Bemis, who was an industrialist that mass-produced toilets. And sometimes when you're in the bathroom, you look down, or you're about to sit down, and you see on the back of the toilet, it'll say Bemis. Family still owns the Bemis factory, producing toilets for our country and others. He had a whole foundation after the money that he made set up to investigate prefabricated housing, and really coined the term modular as a solution for housing. Still use it today. But in other countries, they use different terminology to describe modular that's a little more accurate, not to be confused with a modular organization system, like a modular grid or a design system. So, or not to be confused with Corbusier's modular, right? So they use volumetric building or unit-based building. So this is to describe the box used to build the building. And then offsite is a catch-all category that includes modular and a lot of other solutions. So I categorize this in my book, materials, components, panels, and modules, to try and describe the spectrum of prefabrication. And I even like this better, some work we did with Edinburgh Napier University, where I did my sabbatical, where we categorized two-dimensional elements and three-dimensional elements. And then on the y-axis, there are what's called degree of enhancements. That means the degree to which it's finished in the factory, or what enhancements it has. Does it have insulation? Is it pre-wired? Is it pre-plumbed? And this provides a matrix to help people develop a vocabulary around these concepts, whereas there really didn't exist one before. So you can have everything from open wall panels in the upper left, this one happens to be light gauge steel, all the way down to 90% finished, and they even have brick veneer on the outside, right, in the factory. So here's panelized, and the general concept of panelized is you have usually on minimum 12-foot lengths based upon the flatbeds that are in the factory. This is a typical light gauge steel or wood framed, light wood framed, and at each juncture of a panel to the next panel, you would add another stud, vertical element, and so there is more material being used in this wall, not including waste, just in the product itself. But these are how they're built. In Scotland, this is a very sophisticated factory, fully automated, And you can see it's designed in the computer. It then goes through a nailing bridge. It's put on a butterfly table, so they finish one side, and then the butterfly table flips it to the other side, so they can finish the other side. Fully lined. This one happens to have a stucco finish or a stucco render on the outside. And then vertically stacked on the back of a truck like this. If you do it horizontal, the finishes will crack, so they vertically stack it and then pick it off. And again, they have windows already put in them. And these are called wall panels, roof cartridges, and floor cassettes. That's the nomenclature. In Scotland, about 70% of all of their residential construction, from single family through to multifamily, is built this way. So this is some of the equipment that comes out of Germany and Sweden, where it was pioneered. Weinmann equipment and Randeck equipment. If you start doing research, these will come up again and again. And then trusses built either through a Mitech system or Alpine, which are more US-based. So these are some of the buildings built like this, out of wall panels. Again, not architecturally amazing, but certainly handsome and designed by architects. This is just an example of how one of these buildings goes together. I chose just a single-family house because, for lack of time, but just to show in one day what happens. This is an interesting company. They're actually located in Alberta, Canada. They're probably the most sophisticated in North America. They have a complete German system that builds these. They've gone to multifamily now, and they find greater value doing that. But their goal, and as is the goal that was started in Sweden and came over to North America, is to be dried in one day in a single-family house. The idea is that you don't want any of your materials getting wet. So especially in places like Canada, right, where your weather is very poor. So again, we're still on day one here.
Are these customized things, or are they all off-the-shelf components?
Both. They do both. Mm-hmm. So regardless of what they do, they fully model this in the computer beforehand. There are 2 or 3 systems that have been developed, or software. One is SEMA. It's probably the most sophisticated. SEMA does heavy timber joinery, but it also does light wood frame systems, packages. And it's all pre-cut on what's called a speed cut. And there's maybe 2 companies that produce machines that speed cut. That means you tell them what the size of the stud is, you run it through, and then it pre-cuts it. And it puts RFID tags, radio frequency tags, on all of it, so you can track one stud all the way to its installation in the field. That's the idea. These are roof modules. They're pre-shingled in the factory. Okay, so that's day one. I talked about the difference between these two. A HUD home, or manufactured home, continues to have its chassis attached to it through its life. Whereas on the right, what we're talking about is an IBC or an IRC code compliant built module or box that is put on the back of a flatbed or a trailer and then lifted either through a belt strap or through hooks at the top into place. So it's different. It's built to the standard code. Modular or volumetric built, it does use more wood in that you have double the structure in the floor. So for instance, your floor is built just like a normal floor, and studs, and then you build a ceiling. Usually it's a 2x6 ceiling. And then you build another box on top of that has a floor and a ceiling. So you're doubling up the structure. And then at the joint where the walls come together, it's the same thing. You have a 2x6 and another 2x6 next to it. So for housing, it works beautifully because you get a lot of redundancy. It works really well for fire ratings. And then you can imagine for acoustics, it's very good, right? So here's 4 boxes that are stacked one on top of another. This is for an effort that we're going through to try to develop standard details, which the industry doesn't have currently. So, this is an image from my colleague Ivan Rupnik at Northeastern University. He does studios with students that investigate this industry. And this is a typical factory in the Northeast in the Rust Belt. This is called Simplex Homes. They build single-family houses with architects, and they also do multifamily. And here you can see the panels being floor elements and wall elements being built on raised beds, and then they're put into boxes, and then those boxes all have a station. And just like a car, an auto manufacturing process, each station has a certain takt time. That's a lean term. It means that it can only be there for a certain amount of time, and it's got to move down. And you got to keep that takt time. So in the US, we probably average a takt time of about 4 to 8 boxes a day. And I just got back from Japan, and I was telling everyone I was at a factory, and they have a takt time of 2 minutes. So a box comes out the back every 2 minutes. It's pretty amazing. This is the sequence of operations as it produces the module and then puts it on the back of the truck. This is a project in Philadelphia, just to show as an example. This is a student dormitory. Interface Architects, you probably have heard of this firm. The modules, it's called Modules Project, ironically enough, right? But what I wanted to show is sometimes we think that we assume that an individual unit, whether it's affordable housing or student dormitories, equals a box or a volume in modular. That's not the case. You can cut modules across units, just whatever's most efficient. Just happens that that is probably the most efficient way to do it. So for instance, in Marriott hotels or other hotels, the boxes are cut across the corridor. So they take up one room, corridor, another room. And if they're large, like a Residence Inn, if you've ever stayed in one of those and they have a kitchen, and you can't get the box within that envelope, shipping envelope, you would have 2 boxes that would make up a room, or 1.5 boxes, and then there would be a demising wall in the middle of the module. So the modules don't always have to line up to the space configuration, if that makes sense. We'll just watch one day here as well. I think this is a hotel out near, I think up in Alberta. Champion Commercial Structures built a lot of these. So that's one day. And then someone got tricky with the GoPro. So. But you can see the mechanical ducting in the floor and the ceiling before they're stacked. Some of the innovations that have come out of this industry that I think are pretty fascinating, try to write about. One is the folding roof truss, which is this hinge, so you can fold the roof down in the factory and have it finished, and then when it comes out to the job site, you can erect it. So because the shipping envelope doesn't allow you to get as high as you might need it for a particular roof on the top mod. Another interesting technologies that have come out of this industry that are now making their way into the traditional construction sector are quick connect plumbing and electrical connections. So they're just plug and plays. And they have kind of sharp teeth in them, so you pull in and then it pulls it tight. As I mentioned before, the transportation envelope really is the restriction for a modular box. You can get up to 2 boxes on the back of a lorry or a flatbed. And there's different flatbeds. Some flatbeds, like a low boy, will give you a lot of height, like upwards of 16 or 17 feet on a box, but you don't get as much length on it. Whereas a flatbed, you might be able to get a really long module, but it won't be as high. So it just depends on what you're going for. The ideal kind of dimension for a width is about 14 feet. Beyond that, on the width, you're going to run into significant transportation problems. And the single factor that often roots out modular construction as a choice among project teams is the fact that once you go beyond the 14 feet, then you have lead cars or special permits that cost you out of the market. This is an old project from 2004, kind of some pioneering work by Kieran Timberlake at Yale University. called Pearson Modular, where they pioneered hot-rolled steel modules. And this is the project. You can see the date on there. Doing some brick veneers in the factory and assembling it in a quad. The crane operator couldn't see where these were being set, so they had a little television, and then the camera was on site, and they were having to place these without being able to see the site. I think that's pretty fascinating. And so here's some of the details. This is just a section that's been cut where two mods are joining. So you have the ceiling plane, you have two floors, a floor and a ceiling, and then another floor. And so in hot-rolled steel, they get stacked, and you are using quite a bit more hot-rolled steel. But in a multifamily or dormitory, you get those wall breaks, which allow for sound not to transmit. And then these things are called mate lines or match lines. That's when the boxes come together. And then you usually leave the finishes off about a foot on either side so that in those zones you can finish them, whether it's tile or gypboard or whatever it is. In section, you can see where two mods meet. And say in a brick veneer, you would also need to leave those areas left open with flashing behind it so that you can come in and finish it with the brick veneer. These are three recent projects. Michael Maltzahn Architects project down in San Diego. This is two New York projects, Gluck Plus Architects on the right with the stack, and N Architects for the Housing Authority in New York, all using this multi-level modular construction. You're very familiar with probably with this project in the news. This is B2 Atlantic Yards by Shop Architects that had all sorts of litigation and problems. Really, it was a tolerance issue and not able to get the mods exactly on point, but also there was no way to shim these modules so that the skin would align with as the modules continued to creep in dimension as you got higher and higher and higher. I often argue that, yes, I know we're in this phase of building tall modular buildings, but I think there's actually a sweet spot in the low-rise category. I think that's the case for CLT too, but that's my opinion. So, this is Citizen M, currently being built. This is a photo from about 3 days ago that Ivan took for me in New York City. This is a hotel. These are shipped in from Poland, actually. There's some other offsite going on. I don't want to get into great depth. This is called multi-trade prefabrication, but you should be aware of it, especially students who are going to be in the industry with large contractors such as Mortensen or Whiting Turner or Turner. They are going to this method, which is you either lease a warehouse nearby. It's called near-to-site manufacturing. So basically you're taking your trades that would be on the job site, you're putting them in a controlled environment in the warehouse, and they're building elements in there. So mechanical racks, bathroom pods, things that are really tricky where trades converge and cause all sorts of schedule problems. They're doing in the factory or in the warehouse just near the job site, and then bringing them to the job site and installing just in time. These are bathroom pods that have become very, very popular, especially in hotels. I think the majority of hotels use these now. You don't know you're inside of a bathroom pod when you're in a hotel, but that's what you're using. When does this happen? We've done quite a few surveys for the industry with the National Institute of Building Sciences. What we're showing is that the barriers to using offsite construction are primarily in design and construction culture. This is the way we've always done it, so we don't want to change. That's what the industry is saying. And distance of factory to site. The program of the building may not dictate it. And again, transportation. So transportation always enters in the top of the equation. We've found that about a 300 to 500 mile radius maximum. Outside of that, you usually cost yourself out of the solution. What were the actual benefits if you've done an offsite project? The benefits schedule came up as number one, then quality, then cost effectiveness. You note that that cost is down here, but cost effectiveness is much higher. And the way we define that in the survey is cost effectiveness means cost control as opposed to lowest cost. So predictability. And then during the project planning phase for this project, who was responsible for the decision to use offsite? Who decided it? And the wide majority, the construction manager or the general contractor is deciding whether offsite is used. It's not the architects. I think that probably would be different if we did the survey today, but about 25% of the time the architects are proposing it to owners. For the considered project, when did you collaborate with the contractor performing the offsite work? When did you collaborate with the factory? When did you engage them? And on the light blue, we see when the project engagement actually happened. The majority of the time they engaged them at 50% design development or through 100% design development. Some way in post-bid, but majority there. And then when do you recommend, if you were to do it again, when do you recommend engaging those factories? And they all said right at the beginning in the concept stage. We found this in our own work. We found that when you make the decision as an architect to use prefabricated elements and really think about it critically, past design development, you have a negative schedule and cost implication on the project. And finally, in this section, we're currently doing a study in which we're documenting all these different countries. And what we are finding is that the context in which they are doing offsite construction really dictates the type of offsite construction they're doing. So sometimes we see as architects or engineers or contractors or owners, other countries doing certain things, and we say, we should just do that. But that's not context specific. We have a very unique context here. And so what I'm arguing for are 3 elements we found that have a higher propensity for offsite construction than not. And that is what I call the 3 L's. Number 1, land is really expensive in places that have offsite construction. The labor is really expensive and skilled. And the latitude tends to be really, really high, right? Tend to be in places that rain and snow a lot. So these 3 factors converge. You have a place like America that has relatively cheap land. The labor is immigrant labor that's relatively affordable, and we have pretty good weather. It begs the question, why hasn't this happened earlier? It's probably why. But we're seeing more of it because of the market demand, as I mentioned. I'm just going to go through this very quickly. This is a survey we did where we surveyed accredited architecture schools and accredited construction management schools, the 2 primary fields that are making decisions about offsite construction. And then we also took that industry survey I showed, and we compared them against one another. So we wanted to know what's going on in industry and what's actually being taught in the schools, and where is the gap. Industry said that, have you used offsite construction the past 12 months? 93% said yes, we have, in some form. Education, how often is offsite construction taught? In architecture, 66% said never or sporadically. And in construction management, it's pretty similar, about 60%. So it's not being taught as much as it is being used in industry. What are the most offsite construction product types that you're teaching? Architecture schools said prefabricated exterior walls, curtain wall assemblies, and precast primarily. And construction management, precast, HVAC, plumbing, electrical, that makes sense, and steel assemblies. And industry, which is the gray kind of dashed, lines up pretty well, almost on the money with architecture here, on the money here. So that traced fairly well. What did not was what are the topics that are being addressed, or sorry, typologies that are being addressed, building types. And we see that schools, because of limited time, teach single family, and this has a lot to do with the solar decathlon, I think, teach single family modular a lot, but industry says that's not primarily what we're using it for, offsite construction. What they are using it for is way over here, commercial construction, industrial, healthcare, education. And so there's a gap there between what we're teaching and what industry needs. How is this being done? This is my last category. We did a study where we documented 17 permanent modular construction that's built to the IBC code, modular construction projects, and we compared them to data that we had collected from Cumming Corp, who's a big construction management and cost estimating firm, to see how traditional construction compared to permanent modular construction. This was a long project, about 2.5 years. So we did these PMC projects were the Western United States, the Eastern United States, Central US, Canada, UK, Spain, and Australia. Multifamily, workforce housing, dormitories, healthcare, K through 12, office, hotel, retail. And what we did in a comparison method was both quantitative and qualitative. We did a literature review, found as much information as we could. We then ran a questionnaire. And the person at the top is the architect with the Corpu glasses. The one at the bottom left is the manufacturer or fabricator of the modules, and the one on the right is the general contractor. We triangulated these through a qualitative interview because, believe it or not, one of these individuals likes to paint the picture a little bit rosier than some of the others. So this is a way to try to normalize that data. This is the data we gathered: information, cost information, schedule information, and labor information. We then asked the question, why did you use modular construction? What were the successes? What were the challenges? And did it perform the way you wanted it to? Not talking about energy performance, talking about cost and schedule performance. We compared it to site-built projects, and I'm not going to go through all this. These are all the fields of data that we used to construct those site-built projects that were comparables. What we found are a few examples. The modules case study I've talked about before was 26% more cost-effective in that market and 44% faster build than what was going on at that time. And then we developed these cut sheets where we compared the modules project to the compared project. So you can kind of see like for like. And I think the number at the bottom, which is cost per square foot, is kind of interesting. 158 versus 213. This was all normalized to Q1 2014 data, for lack of a better time, and normalized to Washington, D.C. as a locale. So whenever you have data from different regions or different cost structures, you have to normalize that data as much as possible to make it comparable. This is a project in Joplin, Missouri, a hospital that was quickly built to replace the hospital damaged in the tornado, 30% more cost effective and 60% faster build time. This project was absolutely schedule driven. That's why it came in so fast. That was the mandate. So example, Mercy Hospital was $235 a square foot. Compared hospital project would be $336 a square foot for that region. And then STEM school, this is up in Seattle, and 21% more cost effective, 29% faster build time. Compared at $247 versus $312 in cost per square foot. And then we took all of these and found the mean averages, an average of 11% in cost savings, initial cost, and schedule savings of 42%. This is not statistically significant because we don't have enough samples, but this took 2.5 years, 3 people, and this is the amount of data we were able to get. I would also say this caveat or limitations of the study are pointed directly to the fact that if you didn't perform well and you knew as a contractor on a project, would you share data? The answer is no, you would not. So we were only able to get data on projects that people were willing to share. And those happened to be pretty successful projects. So I've heard over and over again from architects, great study, Ryan, doesn't represent what actually goes on, which is the reason we didn't choose it, it was more expensive. And I would say, well, true, but there are examples where it's working, apparently. So I'm going to skip that. We did a timber volume study. I was really interested in the question of, great, but how much more material is actually used in modular construction or panelized construction? This was funded by the Soft Lumber Board, FP Innovations, and our partners were Method Studios, as an architecture firm in Salt Lake City. We took a building that was a typical 4-story, built on slab-on-grade, multifamily housing project, and we developed a kind of timber volume calculator, and we were able to develop, if you were to build this stick-built, how much wood would actually be used, lumber in this project for the 48,000 square foot 4-level project. And then we compared that to panelized, if you were to build it in panelized or build it in modular. Well, we found that there's a timber volume factor, board foot per square foot of 2.43, and that compares to an increase of 13% for panelized and 19% for modular of just softwood, cut wood, lumber. Total wood, including engineered wood like OSB and LVLs and all that, there was an upcharge of 69% for modular construction. So it uses a lot more wood. What's interesting to me is it's still costing out competitively, which means that the labor rate must be reduced significantly in modular construction to make up for the added material cost. Students of architecture, the two things that you consider in costing, material costs and labor costs, right? And so the question is, how much labor are they able to save? And we need to quantify that still. Return on investment, we decided to work with some developers and ask the question, if we were to come in 50%, 25% faster or 50% faster on a project, just in general conditions, how much would that save you? And we found that it's about $10 to $20 per square foot. And so for a developer who says, I can get in faster and save that money, it's worth it to me. So this is the kind of quantification studies we have been doing over the last few years, just to try to make the case and see if it makes sense for certain audiences. So in conclusion, I noticed in the call for this semester's lectures, there was this question, are architects master builders or are they expert coordinators? Of the two spectrum, right? Opposite sides of the spectrum. Master builder comes from Brunelleschi and the idea that the architect very much is leader of this process or does a lot of it themselves or even owns a factory themselves, right? They're prefab architects. On the other side, the expert coordinator is basically like an orchestra director who's orchestrating all these parties in this hopefully beautiful symphony. My argument is, number one, I think it's a panacea, meaning I don't think there's a silver bullet to this question. I don't think we're a master builder or an expert coordinator. I think it depends on the situation. There are a variety of architectural practices out there. Some want to own factories, some don't. Some want to lead processes like Gluck Plus in New York that are contractors also. I embrace all forms of architectural practice, right? And I think they all have merit. It's contextually contingent. It really depends on the context, whether we act as master builder or expert coordinator or anything in between. And finally, I wasn't taught this in school, but I've come to realize it through practice and research, it's a tough thing to own up to, but the fundamental question of architects is what is their value with respect to making buildings in the end game. If we are not valued, then we won't have work. If we are valued, then we will have work. And so the question I always ask is, how do we continue to push our agenda forward while creating value for that industry? Now, let's not go into the conversation or question about what is societal value or what's not societal value. That is a big question. But in offsite construction, in prefabrication, and in the role of architects in that enterprise, if we don't create value, fundamentally we won't be a master builder or an expert coordinator. We'll be relegated to the outskirts of the building disciplines. So, thank you.